We're live? Cool. Hey, welcome to the SIG Apps introduction. Some of you guys I recognized from the deep dive last night. Some of you guys are new faces. I'm Kenneth Owens, software engineer at Google.
And I'm Janet, also software engineer at Google.
And co-lead or co-chair now, based on the new charter of SIG Apps. And this is just going to be an intro to our SIG. Well, actually, technically, your SIG. So, as I was saying, the current chairs are Anand Abdulhussain from Bitnami. He couldn't be here today, unfortunately, and neither could Matt Farina of Samsung. Recently retired from the SIG, and one of the founders was Michelle Neroli. She is here, not in the room, but at the conference. Microsofter, formerly of DS, and she's currently in the CAGE steering committee.
So before we start, by a show of hands, how many of you are at the SIG Apps deep dive meeting yesterday? Okay. And how many of you are already attending SIG Apps meeting regularly? And how many of you are new to SIG Apps and want to learn more about SIG Apps? Yay.
Cool. So let's talk a little bit about what SIG Apps is. Best way to do that is by our goals. So primarily what we do is we discuss running and defining applications in Kubernetes. These are APIs, SDKs, the core controllers, the workload controllers, package management tools like Helm, other tools like Draft and Compose, KSonnet. We work to improve the Workloads API to better support application development. A lot of the people, I'd say all of the people who are contributors to the Workloads API are members of SIG Apps and tend to attend. So like, if you look at apps, they generally leverage the Workloads API. So that interface between, let's say, Helm or KSonnet and Kubernetes tends to be the Workloads API. And for people who don't know what that is, it's deployment, daemon set, replica set, pod, so forth and so on. So SIG Apps acts as a forum for the community, operators, administrators, tool developers to interface with people who are core Kubernetes contributors and even potentially to become core Kubernetes contributors if they want to. The other thing that we kind of do is, so Kubernetes is kind of a tiered stack, right? Like one of the most external APIs for most people is apps, the stateful set, daemon set, replica set, deployment. But these leverage other primitives, which Brian calls and Tim tend to call nucleus primitives, like services, storage. And then kubelet and the API server, API machinery. We will also act as an interface to kind of look at what people are doing in the community, drive the development of the Workloads API, and drive requirements into the core and into nucleus to make modifications there. We try to be the voice of people running applications in Kubernetes as well. So people who are coming into the community saying, you know, this works really well for us. This doesn't work really well for us. These are the requirements we need. This is what your system does well. These are the production use cases it doesn't solve. We'll be a voice in the overall community and carry those messages back to the steering committee and to SIG architecture and say, well, look, you know, we're Googlers and we did this thing. We wanted to run at Google scale, but for the, you know, the SMBs or for the startups, the requirements aren't really meeting their needs. It's not really solving their problems, and we should probably do this instead. And we try to encourage contributions from the community. So we do our best to try to shepherd commits from people in SIG Apps into the API and into Kubernetes. And we love demos and features, and that's kind of the way that we drive our conversation. So every time we meet, we try to have at least one or two demos of either updates to existing tools and well-known tools, or new features or well-known features.
So we have a regular weekly SIG Apps meeting. It's 1 hour long and starting at 9 a.m. PST every Monday. And what we discuss is that we usually start with an introduction, some announcements within the SIG, and sometimes we have the survey and we'll report the survey results there. And then there are some developers are going to demo the tools they build to either deploying their applications or some tools to make it easier to run your applications in Kubernetes. And there will be project updates, either the project updates from Kubernetes core APIs or Helm or other sub-projects. And then we'll sometimes have a scheduled discussion topics. For example, we recently have a discussions on the app cap, the app definition, like what's an app, and then some open discussions for any other things that people want to discuss. And then we just talked about Workloads API. So how many of you are familiar with Workloads APIs? Okay, I see a few. So I'll give an overview of those Workloads APIs, and both Ken and I are developers on Workloads API. What Workloads API means is that that's the APIs that Kubernetes provides for you to run your pods, and they are going to be running in different patterns. So for example, we have the stateless workloads, and that's managed by the first three APIs. The first one is the deployment API. It's going to help you to deploy your stateless pods. What that means is that your pods are disposable. They'll have the same identity, and you don't care if one dies, you'll create another one. So for example, you have your web applications, you can run it in the deployment, and also deployment supports the rolling update feature, and you can also roll back. And then also it's in so we have a concept called API version. So you have an API group and a version. V1 means that it's under apps V1. That means it's V1, it's GA, and apps means it's under the app API group. Then there's the second one is a replica set. It's also under apps V1. And what it does is that it's actually an implementation details of deployment. So you don't really need to create that or use that. It's just something that deployments create to have the replica set controllers to create more pods, and that's it. And it's also for the stateless workloads because it's part of the deployment implementation detail. And there is also replication controller. If you don't know what it is, you probably don't need to care about it because it's some legacy design that we try to steer people away from. So if you are thinking about what it is, just use deployment instead. And so that's all for stateless workloads, but you still need something that's stateful. For example, your database, your cluster applications, then you'll need your pods to each have its own, maybe its own storage or its own identity or its own network identity, and then stateful set gives you that. So you can, with stateful set, you can deploy a number of similar pods, but each pods will have their own storage, and then they'll have their own network identity, and it's pretty good for databases. For example, we have seen people using stateful set to run Redis or run Postgres in production with stateful set. And it's also GA, it's under apps v1. And then there are also batch jobs that you want to run. For example, you want to do some batch processing. You want to, for example, I have a pile of emails that I want to send, or I want to do some big data stuffs. I want to do some batch processing, then you can use job to do that. What job does is that it creates a bunch of pods, and the job can specify how many pods can be running in parallel at the same time. And you can say how many needs to complete before the job is done. And the big difference between job and other workloads APIs is that the pods that job creates is going to complete, it's going to exit, because you don't want your web applications running in your deployment to terminate, or you don't want your database in stateful set to terminate. But for job, usually you want a job to finish after it's done, and then you store the log somewhere for you to access. So that's a big difference of the job and with the other APIs. So job is under batch v1, it's also GA. And then there's cron job. What's the difference between cron job and job? So cron job allows you to create job at a certain time. You can say create one job every day or every month. And that's a big difference. So cron job is under batch v1 beta 1, and we're going to make it GA in the future. And the last one is daemon set. So daemon set, from its name, is you can probably guess what it does. So daemon set is an API that allows you to create pods running on every single node, like a daemon on each node. For example, you can use that to deploy a logging daemon or some network plugin that's running on every single node. And it also supports the rolling update feature.
So what's the rationale to make the cron job a different type instead of being featured?
So the question is, why do we separate the cron job instead of implementing it in job? So at first we have job, and then we create cron job because people want to have more, to be able to schedule job and by the time,
So I would say,
yeah.
I would say, so we have this controller. If you've ever looked at the internals of Kubernetes, right? The job controller is good at one thing. It's going to launch a bunch of pods based on the parallelism of the job, and based on their statuses, aggregate it, and say the job's complete, either failed or successful, right? So we've got that already exists. Two ways you could add cron functionality. I could bolt it into that, or I could use what's already existing and functional, and then compose on top of it. And generally speaking, inside of the API, we favor composition as opposed to aggregating new features in, right? So in theory, you could have deployment launch pods directly, but the reason deployment uses replica set is because replica set is good at producing n replicas of a particular pod, and deployment's good at like scaling replica sets in order to achieve features like rolling updates, roll forwards, roll backwards, and so forth.
We prefer separate the controllers to make one controller focus on one thing. And when I say controller, that means the controller that runs that implements the logic behind the Workloads APIs. Oh yeah,
so these are some future directions for the API. This is kind of where we're taking it.
So the first is what I just mentioned. The cron job is going to become GA. And then the daemon set that I just mentioned, it will be using default scheduler. What that means is that daemon set right now, it creates pods directly. Because it creates pods on every single node, so it doesn't need to go through the default scheduler. And what default scheduler does is that when other controllers like deployment or stateful set, when they create pods, they are not going to know where the pod is going to be scheduled on. So the default scheduler then comes in and look at the pods and look if it's scheduled or not. If it's not scheduled yet, it's going to assign a node that has enough resource to let the pods being scheduled there, and then Kubernetes is going to run the controller of that pod. So in the future, we want to, instead of having daemon set to schedule the pod themselves, we want to move that to scheduler for a few benefits. First is we can make it easier to do pod priority and preemptions, because if we have a daemon set to do the scheduling and also the default scheduler do the scheduling, then they don't have a consensus on which pod is more important. So you can have the race like the scheduler tries to schedule a pod here, but the daemon set just decided to schedule a pod with lower priority there, just because they are different components. So we're trying to solve that with this move, and also we want to move some complex scheduling logic like tense toleration things outside from the daemon set and centralize it in the default scheduler. And also there's a proposal for the topology-aware disruption budgets. And what that means is that, so for now, the Workloads API supports the rolling update feature. The deployment, the stateful set, the daemon set, you can do the rolling update. What that means is that you can, shut down one instance, one pod at a time, and bring up the new instance one at a time. But you cannot do that, across failure domain. So if I want to update one failure domain at a time, I cannot do that easily today. I need to maybe create multiple deployments or stateful set across different failure domains and manage that individually. So we are proposing this idea to have a disruption budget for each failure domains, and then we can say, I can only tolerate this number of pods to be killed within this failure domain, and that give you some safeguards against your failure domains.
So how many of you guys use stateful sets at all? Anybody? Okay. And do you use those stateful sets with persistent volume claims? And do you use dynamic provisioning on some type of cloud provider or in your, so stateful sets got this thing, right? We don't actually respect scheduling predicates, right? So if you specify an anti-affinity, what ends up happening is the volume provisioner is going to round robin schedule your storage across zones, and you say, I want to place my pod here. Well, what it actually is going to do is place your pod where you've allocated your storage. For most clouds, PDs, EBS volumes, they're zonal resources, right? So if you're trying to get high availability by getting a reasonable distribution across zones, you'll get it, probabilistically, because we're round robining across zones anyway, but you can't actually specify it in the pod. So Michelle she's a member of SIG Storage, has kind of fixed that. She's integrated volume provisioning with the scheduler. So prior to provisioning the volume, it'll look at your stateful set or look at your pod with the PVC, determine what your scheduling predicate is, and actually schedule your volumes in an appropriate way so that you'll get the distribution you ask for, not the one that we hard-coded. Under replication check for pods. So anybody running Elasticsearch? Anybody running Elasticsearch in Kubernetes? Okay, so you're probably aware that if you try to run it in a stateful set and then you do a rolling update, requires quite a bit of duct tape in order to not knock the pod over, leave the cluster under-replicated, and you still want to have a readiness check, and you don't want that readiness check to communicate under replication. So, we always said stateful set was going to be bring your own batteries, require a little bit of duct tape, but that's just too much duct tape. And it kind of is applicable to a wider range of distributed systems. So we're going to try to add an under-replication check to be able to say, okay, don't knock me over. If you do, I'm under-replicated, but I am ready and I can serve traffic. And that's really to address a need for Elasticsearch in specific, but a broader category of distributed systems in general. And then termination reason signal for pods. So anybody running Cassandra? Anybody running Cassandra in Kubernetes? Okay, so some people, I'm aware of some people who are, and one of the big problems there is that So what do I do, right? I'm a base storage system, and I'm not uniformly replicated. If you knock one of these pods over, I have two choices. I can either assume I'm going to come back fast and not replicate, like, let's say 2 terabytes of storage across the top of rack network switch. Or I can say, well, if you knock me over, I'll be under-replicated, and I'm not going to go down until I re-replicate all of my storage. So I don't have my key space under-replicated at all. Both are really needed, right? Like during a rolling update, you have a very high probability your pod is going to come back and get rescheduled. You don't want to re-replicate your storage. And actually, you'd have to do it twice because you'll have to repopulate the pod when it comes back up. That gets super expensive, particularly if you're spread across zones. So really, we just want to be able to send a signal to the pod saying, okay, you're being terminated for scaling, so you're not coming back, or at least the operator's intention is that you're basically being decommissioned. You could intercept it and take whatever actions are necessary to appropriately decommission the pod and re-replicate the storage. Or to say, okay, you're going to come back real fast. If you don't, it's a problem. We should probably block the rolling update anyway. So don't do anything. Just realize you're going to die. Go over, but please don't beat up the network by re-replicating all of your storage. So how many people in the audience are Helm users? A lot of you, okay. So how many of you are, I guess everyone's on Helm 2. Helm 3 is not really a thing yet. So Helm 2 has a few announcements. The 2.9 release is out, newer one. It's stability focused, mainly bug fixes, and that's pretty much what we're going to do with 2.9 going forward. Helm 3 is probably what most people are really interested in hearing about. So the proposals merged. They've decided in broad strokes what Helm 3 is going to look like. And they've started building it. Tiller's gone away, so there is no server-side component at this point. Charts are being updated with libraries and schematized values. We've added a notion of lifecycle events with an emitter-handler model, which is something that's fairly interesting and you might want to look into if you're interested in the future of Helm. They're embedding LAO scripting. They're adding 2 CRDs, so release and release version with secret. Resources created by hooks will now be managed, and a Helm controller project's going to be started for like a DevOps workflow. So kind of think of like a Git flow for Helm. Cross-platform plugins in LAO that only have a runtime dependency on Helm, so you're not locked into pulling in a bunch of other stuff. And a complementary command to fetch and push packages to a repository are some of the major outlines. And the basic status is right now it's starting implementation, so a lot of these are open issues. A lot of these are proposals. If you're happy with the direction, that's great. If you're not happy with the direction, now's a good time to chime in. If you want to contribute and help shape the direction with your contributions, now's a great time to get involved. Is there a question?
Yeah, just like is there a mention of like different? Is there a discussion around different templating options?
So the discussion is there a discussion around different templating options? So in Helm 2, you actually can replace the default templating option with your own templating option. It's not trivial, but if you wanted to do it, it's possible. And in Helm 3, you'll be able to do the same thing. So if you don't want to use the default templating option, you could bring your other. And I believe they're working to make it actually a little bit easier. Not that it's like insurmountably hard to do in Helm 2, but honestly, when people have said, I don't like Helm templates, and they've been pointed in the direction of how to implement their own templating, no one's like picked up that stick and run with it. So they're.
I just feel like it's a pretty nasty user experience.
You know, it's kind of a divisive thing, right? Like some people are like, this is great, I love it. Other people are like, I hate it. It's one of those polarizing things like, you know, tabs or spaces, right?
Yeah, it's just, I mean, it's kind of hard to work with templates on top of YAML where you have to do implementation and things like that.
For sure.
Mention merge network contexts that are kind of controlled.
I mean, I don't think they're going to completely rewrite all of the templating in order to.
Yeah, just it'd be really great to see us moving towards a nice user experience.
I think the kind of general consensus is we're going to give you the hooks so that you can bring the user experience that you want. Also, you might want to talk to Brian Lyles about the future of KSonnet and how that's going to integrate with charts.
Yeah.
that might be interesting for you too.
But I've been mostly wondering how much of that is currently running off for Helm. So it seems like it isn't specifically anything that you mentioned that a bit easier to swap in templating engine. So that already sounds like it needs to be.
Yeah, cool. Sure.
Yeah. Yesterday in the slides you were showing you were working on the app CRD.
Yeah.
And Helm is working kind of a Helm or chart or app CRD. How does it intersect or how does it overlap? Or
So if the app CRD has good utilization and is generally ready, Helm's community said they want to adopt it and integrate it to have applications inside of Helm. But the app CRD controller and the app CRD are somewhat orthogonal. Helm does packages. App CRD is mainly about live instances of applications. Go ahead. Do you want me to go back? Between Helm 2 and Helm 3? Now that I actually can't answer. I would have to get one of the Helmers. I'm sure they're going to allow you to migrate your charts from Helm 2 to Helm 3. But I don't know how, if there's, since it's not built yet, I think it's in everybody's mind, how do you migrate? I don't think there's formal instructions, right? I think how you migrate from Helm 2 to Helm 3 instructions are going to come out as Helm evolves and as more effort is put into actually shipping it. But knowing the people in the community, they're not going to release Helm 3 with no instructions on how to upgrade from Helm 2 to Helm 3.
So for charts and apps, for charts, so if you don't know what chart is, it's like a package of the Helm, of the Kubernetes apps that you can deploy through Helm. And we have the charts community have an hour meeting every other Tuesday. And there's also Cube Apps. It's a website for a web UI for Helm charts. And they just released the 0.60, and then Helm upgrade is also supported.
So we talked a little bit about the application CRD. We opened a KEP. The community didn't like the process of KEPs in general, so we opened a repo. And we opened a bunch of issues, and we started working. The repo is listed on the slides, and we're looking for contributors and opinions as well. To expand a little bit on what we touched on, the application CRD is basically a way to aggregate the pods, stateful sets, services, PVCs, persistent volumes, in such a way that you can identify that these things are part of the same application. So composability, dependencies, and the exact semantics of aggregation are still somewhat of an open question, and we're looking for community contributions. Even if you're not interested in contributing code, if you're just interested in contributing your experience and what works for you, it would be really valuable because that allows us to make sure we're building the right thing and that what we build as a notion of an application is useful for you. And that's what our primary focus is. We don't want to build things that, yay, we built this new feature, but nobody's using it because it doesn't really represent an application in any way that's meaningful to me, right? So if you're looking for something to get involved in, that's like as an intro to Kubernetes and first contributions, it's a good place to start.
What's the main difference between an application and Helm chart?
The question is, what's the main difference between an application and a Helm chart? A Helm chart is really a package, right? So the semantics of the application CRD are really about how you interact with the things that have been deployed once the package is installed, right? So you have a Helm chart that installs WordPress. Once you install it, you get, let's say, a stateful set with a MySQL instance and either a stateful set or a deployment with the web servers that interface with the MySQL instance, right? And there's really nothing that allows you to understand that any of those components are in any way related if you were to look at them in a UI or if you were to do a kubectl get. The application CRD solves those problems. It doesn't solve the installation problems, and it doesn't solve the packaging problems. Helm is a good package manager. It's probably the most dominant one in the community right now. There are other package managers out there. We don't want to go resolve that. We don't need yet one more. So we do think we need something to aggregate the components once they're installed to be able to interact with them as a whole and to do intelligent things with them as a whole.
So yeah, it's an application is then released, right? Will Helm change the wording much? Like
Well,
currently,
the application CRD doesn't have a notion of release. Helm's notion of release is really just the version of the package that's installed with the updates. I'm not sure I don't think they intend to change the wording, but I mean, if that's feedback that you have, I would definitely go to the Helm contributors meetup and just say, come on,
That's a line.
yeah.
Question.
Can you explain what the end user experience of using the app CRD is supposed to look and feel like? Like look through the CRD spec and everything itself, but how do you envision people using this?
So we are allowed to say that the GKE UI team is actually integrated now, and it's probably going to get integrated into the open source UI as well because they're adopting the dashboard. Yeah. So what it ends up looking like is when you install, let's say, WordPress, you'll see an icon for WordPress, and then you open that up and you see a tree of things. You see like the services related to WordPress. You see the stateful set containing the MySQL server. You see a deployment containing the web servers. Then you can expand on those, and that comes up in a Workloads tab. In the GKE UI, we have a separate applications view of the entire system.
I guess the question is more about who's going to be writing are users expected to write them for their own apps, CRD, or is there tooling like Helm or something to generate one for?
So yeah, what is Conflate called now?
Customize.
Customize. So we're looking at allowing Customize to just inject that directly, right? So it's simple enough that you should be able to, via labeling, discover it and generate the CRD directly. We don't want users to have to manually do that.
Well, seems like it makes it sort of consider very specifically how this relationship is going to work out with respect to Humphrey, as Humphrey will not explicitly define. Perhaps the application CRD could be part of that, and because right now I think conceptually there are some clarity with release and chart and how those things in the cluster, and the star balls, which I don't know if those into the home star balls, star balls, and those chart star balls pre-rendered things, and they still have time to take a long time, sure. So it's kind of like conceptually you nice to kind of have this immutable object that gets produced, to which you compile to that you use as a unit of shipping application properties. So one could produce that kind of object, another thing could produce that kind of object. In terms of application CRD could be just about in the right spot for that purpose. I'm not entirely sure about the details, but it seems like it could be. I think that is an interesting discussion to be had. Maybe the equivalent of a jar that helps or something where we kind of compile a bunch of things and we deploy that to 20%. Any tool can produce that. The moment we keep talking about the sort of interoperability layer, we say, oh, Kubernetes API is interoperability layer for us, and that feels like we're still in the land of writing a makefile for a C project where we compile individual C files to individual object files, and then we link them, and we can get that completely wrong very easily. And it would be nice to kind of have equivalent of a jar, for the lack of better sort of idea for the moment. And I was suggesting that maybe good.
For sure. We talk to the Helm guys on a regular basis, but that would definitely be good feedback to give to the Helm guys. It's a little bit lengthy for me to repeat that over mic, but for the recording. But yeah, definitely I would suggest either coming to the Helm meeting or even come to SIG Apps and just give that feedback there.
Question?
For the application CRD, is it in scope to talk about services that are not on Kubernetes? So in the world where you are straddling, you've still got legacy data stores or whatever, and you've got new applications which have sets of microservices, but they're all relying on some some storage or whatever that's not on Kubernetes. Is that in scope?
So the question was, is it in scope to think about services that are not actually being hosted in cluster when talking about the application CRD? And the answer is probably, maybe. So, I mean, like with Kubernetes, it brings up some interesting ideas of how services are hosted, right? Like you can have a white box service, which is pretty much hosted in cluster. You can have a black box service, which is something that you connect to, like a relational database that's provided by a cloud provider. And you can have a gray box service, something that's hosted in cluster, but someone else who's in cluster is using it as a white box service. I think Kubernetes supports all of these, and we talk to the open service broker guys a lot about what the difference between a service, and I don't mean the networking primitive, but a service that we traditionally think of as engineers as services, is an application and how the application CRD should interact with OSB. I think the open service broker and their notion of provisioning and services is kind of like the community standard going forward with how to interface services with your cluster. How applications and services interact is an open area of discussion that is we would definitely like to have feedback on.
So this is our last slide. And we also care about other ecosystem projects. For example, Compose, which is a quite popular subproject under SIG Apps. What it does is that it translates a Docker Compose file into Kubernetes resource file. And then we have Monocular. It's a web UI for Helm chart repos. And Chart Museum, it's a Helm chart repo with the support of Amazon S3 and Google Cloud Storage. And Cache is a way to declaratively define and deploy your applications. And then Meta Controller, it's a framework for you to write a custom controller without, knowing a lot of details about how to write a controller. You just implement a logic and you fit it to Meta Controller, and you can write it in any language you want, JavaScript, Python, and you can fit it to Meta Controller, and it will run the control loop for you.
So Audit to RBAC is a tool out of Red Hat. Discovering when you write a controller what RBAC rules you need for the controller can sometimes be tedious. It is maybe not the most compelling story that you would run the controller and then look at the audit logs and then turn them into RBAC. It kind of is the reverse way you generally think of using RBAC, right? But it's honestly been a useful thing. So this allows you to basically run through that audit log and generate the RBAC rules based on what the controller actually does. Netsil is a really interesting thing. So they've demoed at SIG Apps. It's a Kubernetes network monitoring, and it's not like service mesh, but it provides the same kind of functionality in terms of looking at the network utilization via just services, right? It's something that if you haven't seen, you might want to check out. Draft makes it easy to build and compose applications on Kubernetes. Scaffold's a new one. This is out of Google. And it facilitates continuous development for Kubernetes applications. They recently presented at SIG Apps, and some of their members have been very active recently in the SIG Apps community. And Kubeless is like a native serverless platform. And we've got a lot more. There's many, many more things in the ecosystem that are part of SIG Apps. These are kind of the officially maintained things that are in SIG Apps. And that's the end of the presentation. Are there any questions? Any more questions?
If you want to contribute to SIG Apps, the best way is to start with the meetings, the weekly meetings, or any other thing?
There's a lot of different ways you can contribute. So you can start with the weekly meetings. That's a good way to get to know everybody and just like come in and see what's going on. If you're more comfortable like just taking on an issue and opening an issue, you can go to our landing page, look at any of the projects, and start contributing code. We're always looking for contributions, both for bug fixes, for new features, and for documentation. So all of those are good ways to get involved if you're looking to get involved.
So on GitHub issues, you can search by labels, and you can filter the SIG Apps label to find the SIG Apps issues or PRs. And also you can go to Kubernetes Slack, and there's a SIG Apps channel. You can also interact with people there.
Do you have any plans on looking at the issue with having a sidecar while running a job?
So the question was, do we have any plans on looking at the issues with running sidecars with jobs? And I assume you're talking about completion? Yeah.
Your job completes, you main process, your sidecar doesn't know about complete it,
Yeah, we are aware of that, but I think to solve that, we need collaboration with the SIG nodes,
Yeah.
the kubelet team.
But I mean, it's something we haven't actively put on the roadmap to go do. But yeah, like she said, we're definitely aware of it. If it's something you would be interested in contributing, that would be awesome. Like, it's not something that, like, I think you would get a lot of pushback on, like, hey, we don't want this to happen. It's just not been on the highest tier of priority.
There is a related topic which was also, I think, overlapping with the signals regarding init containers and the restart policy. And since that is the containers, restart policies is more for the container restart rather than the pod itself. So the init containers don't get restarted to be executed if the container restart. So there are some use cases that I encountered where that might be useful thing as well. So I was not sure which SIG to talk to, whether that's SIG node, because most of the things will be executed with the kubelet. But also there is a impact from the pod restart policy API. So is it SIG apps that I should talk to, or is it SIG node, or both?
So the question was, with init containers and with pod restart policy, basically you're not going to rerun your init containers unless you get a pod restart. And the behavior you were looking for is to have the init containers run on container restart.
In some use cases, not all.
So the behavior is, you're looking for more flexibility in that behavior. And the actual question is SIG apps or SIG node the right place to ask that question? And I would say the answer to that is yes. Like, that's one of those overarching questions. It's going to have to be a collaboration between SIG apps and SIG node. And if there was disagreement there under new governance, we would probably kick that up to SIG architecture. But I mean, like, generally, if SIG apps and SIG node basically agree that, okay, this is the right thing, we should do it. The only thing I would say offhand is that, like, given that pod is V1, there would have to be a somewhat compelling reason to do it, as opposed to just, well, it's a nice thing to do. We don't want to just add code because it seems nice. Like, I can think of ways you could use additional containers to get around init containers in the way they work. But if you can present a very compelling use case at either SIG apps or SIG node, you could probably get traction. I'm getting the wrap it up signal. So thanks everybody for coming out, and I hope to see you at SIG apps meetings.
Yeah, thank you.